Hi everyone and welcome to Gumdrop buttons. So this is one of my favorite lessons on equivalence in fractions. You imagine you are the gingerbread man from Shrek and you love your buttons. So you have 3 buttons, 2 green, 1 red. So therefore you have 1/3 red and 2/3 green at the start, like so. But then a mate comes along and she is jealous of your buttons. Not those Gumdrop buttons, I want the exact same set. So she wants the exact same as you. And so she makes the set. But now instead of just 1 out of 3, which it still is, because it's still 1 out of 3 for this gingerbread person and this gingerbread person. But if we talk about the whole lot, then the red is 2 out of 6. So we can record that it is the same as 2 out of 6. And the green is 4 out of 6. So 4 out of 6. So we've recorded that equivalence. Then another mate comes along, or another one shoots out of the conveyor belt because we're at the gingerbread factory here. And of course, the factory makes their gingerbreads the same, and maybe it's Christmas, so it's red and green. So we've got now still 1/3 on each, so it's still equivalent to 1/3 for the red, and it's still 2/3 for the green. But if we look at the red out of all of them, we have 3 red out of 9 buttons altogether. So that is the same as or equivalent to 3 out of 9. Likewise for the green, we look at the green and there's still 2 out of 3 on each. But if we look at all of them, it is 6 out of 9. So we have 6 buttons out of 9 that are green. And we can just keep going and going. I won't bore you with too many more examples, but one more. We still trust that it's 1/3. We still trust that it's 2/3. But all together now, we have 4 out of 12 buttons that are red. So 4 out of 12. And in a way, this is better than just telling the kids double, 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 because we got more than double. We went to the 9 before we went to the 12. So it really increased as a 1-to-2 ratio. And then we have for the green altogether 8 out of 12. So you're sort of trying to use your supertizing or your superhero eyes to see how many you have as well. Now you can do this another way. Another way to set this up is an array type of structure rather than gingerbread people or skydiving people, as some of the other lessons have. So you can imagine, let's do a different fraction, that we had sport balls in the buckets at school and the PE teacher distributes all the balls at the start of the year and then asks for the same amount back. So let's say this is a footies. So we've got 2 red footies and 3 netballs here. So we've got 2 out of 5 that are red. So we might go 2 out of 5 that are red and 3 out of 5 that are blue. All right, so now we'll work with that fraction. Now that's the sport bucket for one class, but every class was given the same buckets of balls at the start of the year. And now the PE teacher's going, come on guys, you need to give them all back so I can reset them up for the next year. So altogether, with 2 classes next to each other, we have still 2 out of 5 footies in each class and 3 out of 5 netballs. But we also have 4 out of 10 for the footies. So 4 out of 10 are the footies. And we have 6 out of 10 that are the netballs. And we'll do one more layer, but you can just keep going on forever, right? It would just keep going on. It would keep building the equivalent fractions in a really structured way and in a way that students can build conceptually just by following essentially the pattern of repeating the same arrangement over and over again in the same proportions. So now we still have 2 out of 5 footies and 3 out of 5 netballs. But if we look at all the classes, all 3 classes, we have 6 out of 15. So 6 out of 15, which is the same as 2/5. It's the same proportion as 2/5, or the same value. We also have altogether 9 out of 15 for the netballs. So 9 out of 15. And on and on and on we could go. So my personal favourite's the gingerbread, for sure, because of the hook. But you can do it with arrays quite strategically as well. And the arrays will usually hold a bit more because the gingerbreads, I mean, even if you print them in A3, you know, you'd have to make quite big gingerbreads or have quite small buttons to go to fractions like sevenths or eighths for equivalence. But the array can hold a lot more on the grip mat. And that is just one of the many, many ways we tackle equivalence at Top 10, because it is the most important concept for fractions after the outer of understanding. So you just need to build it again and again and again. You're going to rely on it so much for addition and subtraction of fractions later, for converting fractions to percentages and decimals. So if it's a shaky foundation, you really do suffer long term. So better to put the effort in for so many different multiple representations with materials first, so that you don't have the ghost of equivalence haunting you later in operating on fractions.